All right, for this lesson, we are going to continue talking about integers, and we're going to continue to compare integers and order them, thinking in terms of negative and positive and how that all works on a number line. So we just completed the do now, but go ahead and turn the page and just review those answers for a moment. All right, just check over these answers real quickly, and again noting that numbers to the right are higher than numbers to the left. All right, so go ahead and turn to the next page, and let's summarize that. So in this sentence here, we're looking at numbers increase in value as you move to the right or move up on a number line. Okay, so we want to say numbers increase in value as you move to the right or up on a number line. And similarly, when you move to the left or down, numbers decrease. All right, so numbers decrease in value as you move to the left, down on a number line. And again, our key words here are right and up for increase and left or down for decrease. And we're going to use that information to compare integers. All right, let's take a look at this first example. So, 3 students went to the ocean to go swimming. Chantel is swimming at -12 feet down, so she's well below the surface. Donnell is standing on the shore at 0 feet, and Marissa is swimming at -feet, so she's way down there. Order the number from the deepest to shallowest. All right, so let's first find these numbers on the number line. So we have -12 is right there. We have 0, of course, right there. And then -15 is going to be between 14 and 16, so roughly there. So if we're going to order these, we have to go from left to right, starting at the most left and then moving to the right to go in increasing in order. So this is from the deepest to the most shallow at 0. So that order would be -15, -12, and then 0. All right. Now another swimmer, Tyreek, jumped in the water and swam to a greater depth than his 3 friends. To what depth could Tyreek have swum? All right, so we're talking about a greater depth. So he's going even farther down than Marissa or Chantel went. So there are lots of possible answers here. One could possibly be -16, because that is to the left of -15. So I could have picked any number to the left of -15 to make this true. So let's write that down. Tyreek could have swum to a depth of -16 because -16 is to the left of all the other depths. So you could put a different number there, of course, but whatever it is has to be to the left of -15. All right, go ahead and turn to the next page. All right, let's look at an example here of temperature again. And these are degrees Celsius. Angie recorded the average low temperature in degrees Celsius of major cities during the month of February in the table below. So Minneapolis had a low temperature of -11, pretty chilly. San Francisco had a low temperature of 9, not too bad. Phoenix had a temperature of 12, that's kind of warm. And Salt Lake City went as cold as -9, but not quite as cold as Minneapolis. All right, so question A says, represent the temperatures on the number line below. Now, note that there is no 0 on this number line. So we're going to call one of these somewhere in the middle. We're going to put a 0 because we need to start from somewhere, right? All right, so let's graph each one of these. So -11, I am going to go to the left because I need to decrease. So I have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. So on that last spot, we can put -11. All right, let's do something similar for 9, but now because it's positive, we're going to go to the right. So starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to put a 9 there. All right, and then we have 12, and I can just start at 9 and go 3 more. 10, 11, 12. And then I have -9 again, so let's start back at 0 and go -1, -2, -3, -4, -5, -6, -7, -8, -9. So let's mark that there. I'm going to put some dots at these points as well, just to help us see them better. And this should make sense, right? Between 9 and 11, we know is a distance of 2, and that's what we have here. All right. Between 9 and 12, we should have a distance of 3, and that's what we have here. So that all makes sense. So let's look at question B. Write a statement of inequality comparing the temperatures of Minneapolis and San Francisco, and explain how you determined your inequality. All right, so we are looking at, in this case, Minneapolis and San Francisco. So an inequality means we are using either a less than or a greater than sign. So we can start with either number, but I'm going to start with -11. And when I compare it to 9, I know that 9 is greater than -11 because it's to the right of -11. So my inequality has to open up to the larger number. Okay? So my explanation is that 9 is to the right of -11. All right, let's look at part C. Using your understanding of absolute value and the number line, find the difference in average low temperatures between Phoenix and Salt Lake City. All right, so let's erase. It's not really happening. Okay, so we will highlight in a different color. So now we're looking at Phoenix and Salt Lake City. And it wants the distance between them. So let's take a look on the number line. Here's Salt Lake City, and here is all the way up to Phoenix. So we could count this, right? I can count the distance from 9 to 0 and the distance from 0 to 12. We represent the distance between -9 and 0 using absolute value. So I can say that the distance equals the absolute value of -9 plus the absolute value of 12, because I want to capture that complete distance from here to here, from -9 to 0, and then from 0 to 12. Now, of course, we know that the absolute value of -9 is 9. The absolute value of 12 is 12. So that gives us a distance of 21 when you add them together. All right, so once again, we're making that connection between absolute value and distance, or difference in this case. How far apart are those two temperatures? Okay, go ahead and turn to the next page, please. I'm going to have you work on the next 2 pages of practice problems, so go ahead and pause the video and work on these, and then come back and check your answers. All right, take a look at the answers on the first page and make sure that you have that right. And just taking special notice to this absolute value of -2, we know that value is actually 2, so it gets plotted as 2, and I use the value 2 over here. So remember, this is the same as 2. It's a positive 2, and so it gets marked there on the number line. All right, go ahead and check the answers on the next page. All right, check out these answers on the second page, and just a couple of highlights. Notice I'm talking a lot in terms of number lines when I use my explanations, so that's something to keep in mind, especially down here where there is no number line to really look at because numbers are really big. But again, I know these numbers would go from left to right on a number line, and they would go from, the most deep, which is the lowest, to the highest, which is the least deep. All right, go ahead and turn to the next page, please. All right, using the number line below, plot these numbers and then write them in their correct order. So go ahead and do that, and then come back and check your answer. All right, check out these answers. It was a little bit of a trick because 2 of these numbers were equivalent. Of course, the absolute value of 3 and the absolute value of -3, of course, are the same number. So they don't really go next to each other. They kind of go on top because they are the same value. So probably would do that to you on a quiz. That was just for this last question. All right, go ahead and turn to the next page. So please complete this video assessment and on the paper that I provided, and when you're done with that, you can turn that in and you can begin working on the homework after that.